and we're back at it. Question 10 of a paper 1. Okay, so 2019 paper. Oil tank structure shown below, blah, blah, cylindrical body. So I'm just reading for the bits that matter here. Of length and 2 hemispherical ends. Okay, so there's a cylinder. Well, I'm going to draw a lovely looking cylinder here, which feels sort of like it's on its side, right? There it is. And we've got 2 hemispheres, 2 half spheres. So in other words, we've got 1 full sphere. I don't know. Sometimes I draw a sphere like this to try and get that 3D-ness. Anyway, but you got the idea, hopefully, which means we can work out total surface areas and volumes. And the total surface area is, of course, just that surface area of the cylinder plus the surface area of the sphere, blah, blah. And there's going to be a little bit of algebra somewhere along the way, or just simplifying terms. But otherwise, we've got all the formulae we need here. We've got the surface area of a cylinder, which is kindly given to us, and the volume of a cylinder, which needn't be given to us because you could work it out. I don't know why this looked like this. Doesn't look so neat. Anyway, so determine the value of R such that the total surface area is a minimum. Okay, so TSA min means we must get a function for surface area. So if we can get a function in terms of one variable only, let's say that our variable is going to be radius. Well, it must be radius, value of R. So we get a function for R for total surface area. It's going to be pi R, this, that, and the other. No H's though. And then, of course, if we want to find a minimum, we can derive this and find where it's equal to 0, whatever type of function we're looking for, maxima and minima, and we'll look for the minimum. Okay, so they're all the bits of the puzzle. Let's see what we can do and what information we're given. I'm reading the top part here. Radius R meters. Okay, so we've got the R, that's in the picture already. And it has this picture's hilarious, sorry, because you can see things that were rubbed out and changed. Anyway, sorry. The volume is 1,000. Well, to work out the volume, we'll need to add these two volumes together. So we can create one equation where we know what the volume is, which is, I'm just going to write it just like that, 4 over 3 pi r cubed plus pi r squared h. Okay, and we know that this volume is equal to, did it say 1,000? Let me scroll up and check. 1,000 indeed. Okay, so 1,000 equals 4 over 3 pi r cubed plus pi r squared h. Okay, so from that, we could rearrange our equations so we just have h equals something. We can come back to the algebra for that, but of course you've got that in the memo as well, so I'm focusing on the concepts more here. Okay, then it says that we must find the surface area. Well, the surface area is just these two things added together, right? So the total surface area is going to be of the sphere 4 pi r squared plus the cylinder. Now the cylinder, of course, we've only got the outside. I don't know how to shade this outside. Maybe like this. This outside is what we've got. We're not worried about those two circles on the end, which is the 2 pi r squared, right? Because that bit's inside. We can't see it. So therefore, we've just got I'm reading this formula over here and going 2 pi r h. Well, this surface area isn't just in terms of r, it's also in terms of h, but we know what h is from our previous working. So our total surface area, we can call it s, we can call it, I just went for function, a function in terms of r is 4 pi r squared plus 2 pi r h, whatever you got in that line above. Now h was 1 over pi r squared, I've got my working from before, 1,000 minus 4 over 3 pi r cubed, blah, blah, blah. Okay, so it'll be easiest if you just multiply this thing out so that you've got just a whole lot of nice separate terms, and therefore you can find out what the derivative is and make that derivative equal to 0, and hopefully we can find out where those turning points are. So we have 0 equals blah blah. Might turn out that you get R values that are negative we can disregard. I don't know, I don't have enough detail here to look what it's going to look like, but obviously you'll figure out which one. So you'll solve this whole thing and you'll get a value of R which will give you the minimum. Okay, hopefully helpful. Obviously you got a chance to ask more questions, so let's head to another question.